You are listening to The Vocal Technologist. Spoken tech for your ears.
Okay, so let's get into it. Today we're looking at, well, just the speed of everything and DevOps, cloud stuff, developer tools.
It's moving fast, isn't it? Really fast.
Insanely fast. And we've got some sources here covering some pretty cool advancements, but also, some security things, even a couple of, well, gotchas you really need to watch out for.
Right, those little hidden traps. Always lurking.
Exactly. So what we want to do is kind of sift through all that, pull out the key bits so you can stay up to speed without getting, totally swamped.
Makes sense. Cut through the noise.
And, something interesting that jumps out right away is this tension, I guess, between having central control and letting developers just go, especially with platform engineering becoming such a big thing.
Oh, absolutely. That's a core challenge. How do you let the platform teams manage things, keep governance in check, but not, slow down the developers who need to ship features?
Yeah. And it looks like CircleCI is trying to tackle that. One source mentions their Platform Team Toolkit.
Right. The idea there is giving platform teams one place, a single config, essentially, to manage lots of different CI/CD pipelines across the org so they can set the rules, provide standard templates, that sort of thing. Consistency.
Okay, so they set the guardrails, the framework.
Exactly.
Yeah.
But importantly, developers still get the wiggle room they need to tweak their own workflows within those guardrails. It's trying to find that balance, get the best of both worlds, really.
That makes sense. It kind of fits with this bigger trend we're seeing, right? More abstraction, more automation. Look at Google Kubernetes Engine.
Yeah, GKE. 10 years now, can you believe it?
Wow, 10 years already. It feels like yesterday.
I know. And it's not just for the standard web apps anymore. It's powering serious AI workloads these days, using things like Autopilot to handle the infrastructure side automatically. For better performance, maybe saving some cost.
And this feels important, something you highlighted. Kubernetes itself, even something managed like GKE. It's incredibly powerful, no doubt, but it's not actually secure out of the box.
That is a huge point.
Yeah.
A really critical takeaway from one of the sources. People often make that assumption that because it's so fundamental, it must be locked down. But nope, you have to actively configure the security.
Okay, so that's a major red flag for anyone running clusters, especially as they inevitably get more complex. You can't just deploy and forget.
Definitely not. Which brings us neatly to, well, how do you build security in from the start? Move away from just reacting when something bad happens.
Right, shifting to that security by design mindset we hear about.
In Calico's new version, v3.3, seems pretty relevant here, they've introduced these admin network policy standards.
Okay, what do those do exactly? How do they help?
They basically let the platform or security teams set a baseline security posture across the whole Kubernetes environment. Think of them as like global security rules that apply everywhere.
Yeah.
And maybe even more interesting, they have this staged network policy feature. It lets you test policies, see what the impact would be before you actually enforce them live.
Ah, like a dry run capability. That's smart. Helps avoid accidentally breaking production traffic or locking things down too much.
Precisely. It directly tackles that complexity issue, the potential for configuration drift, just the sheer cognitive load of trying to secure Kubernetes correctly.
Yeah.
It fits right into managing that complexity we were just talking about with platform engineering.
Yeah, managing complexity definitely feels like the recurring theme here. And it's not just governance and security, is it? It's also about operational reliability, like getting applications deployed safely and efficiently.
Right. And look at Amazon ECS, for example. They've really stepped up their game recently, adding built-in blue-green deployment functionality right into the service.
Oh, interesting. So you don't necessarily need separate complex tooling or scripts for that pattern anymore?
For many use cases, probably not. It makes application updates much safer, gives you that easy rollback capability if something goes wrong, all integrated right into the core service. It's another example of making these powerful cloud services more robust out of the box.
It really does feel like a trend, integrating these more advanced, robust features directly. And that push for maybe simplification for the end user. It seems to be hitting how developers actually write code, too, especially tricky stuff like concurrent code.
Oh, for sure. That's a great point. We saw CircleWait come along years ago, which, made writing concurrent code way more approachable for a lot of developers compared to raw threads.
Yeah, it lowered the barrier, but
Yeah.
it wasn't a silver bullet, right? It had its own set of complexities.
Exactly. It definitely helped, but it brought its own challenges. Sometimes these leaky abstractions, things like subtle Thread pool issues, thread starvation, and debugging could still be a real pain sometimes.
Yeah, I've been there.
So now we're seeing things like virtual threads, like in Java's Project Loom, really gaining traction. The whole idea there is to push that concurrency management complexity down into the runtime itself.
Making life easier for the developer again, basically. Hiding the hard parts.
Yeah, letting the runtime handle the tricky, low-level scheduling and context switching more efficiently so the developer can write simpler-looking sequential code that still runs concurrently. It abstracts away some of those thorny details.
That sounds like a very welcome change for a lot of developers, I bet. But, okay, so while things are getting maybe easier or more automated in some of these sophisticated areas, we still got to be careful about the fundamentals, right? The tools we rely on every single day.
Absolutely. You can't neglect the foundations.
Yeah, like Squai. Wow. We saw a source with a pretty critical, almost like a public service announcement about that. Apparently the wall checksum is in Squile. They can actually fail. Silently.
Silently. Uh-oh.
Yeah.
That's usually not a word you want associated with data integrity checks.
Right. The source detailed how if Squide is reading the write-ahead log and finds a checksum mismatch on a frame, it just discards that frame and all subsequent frames in that wall file without throwing an error or alerting the application.
Wait, hold on. So you could be losing perfectly valid committed data just because an earlier frame had a corruption, and you would have absolutely no idea it happened.
That's exactly what it sounds like. A completely silent failure mode, potentially leading to data loss. Talk about a hidden pitfall, especially for such a widely used database.
Wow. That really, really underscores how vital it is to truly understand the underlying mechanics, the failure modes of the tools we build on, even the ones we consider totally reliable and fundamental.
Definitely. No system is completely foolproof. You always need that underlying vigilance, that deeper understanding.
For sure.
So, wrapping this discussion up, what's the big picture feeling here? It really seems clear that our tools, platforms, everything, it's all evolving incredibly quickly, getting more powerful, definitely way more automated.
And in some instances, yeah, maybe more secure by design, or at least offering better primitives to build more secure systems.
True, true. But with all that increasing power and abstraction comes, well, you still need continued vigilance, right? About the complexity it introduces, even if it's hidden complexity. And watching out for these sneaky, silent pitfalls like that SQLite checksum issue. You just can't afford to take things for granted.
Which, raises a really interesting question for me. As we push more and more of this inherent complexity down, either into the runtime like we discussed with virtual threads, or abstracting away entirely with platform engineering, are we truly simplifying the developer's life in the long run?
Or are we just creating new, maybe more opaque layers of abstraction?
Exactly. New layers that will eventually require their own deep understanding, their own specialized troubleshooting, their own investigations in the future. It's a really fascinating balance to try and strike. Where does the complexity live?
It really is. Definitely something to mull over as you're architecting and building your next big thing out there. Well, thanks for tuning in with us today for this exploration. Keep learning, keep asking those questions.
And stay curious about how things really work underneath.
Absolutely. We'll catch you next time for more insights.
Spoken Tech for your ears.